Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve the first two questions from Probability and Statistics 1. And these two questions belong to paper 9709/52 for the session October-November 24. Let's read question number 1. It says, at a college, the students choose exactly one of tennis, hockey, or netball to play. The table shows the members of students in year 1 and year 2 at the college playing each of these sports. One student is chosen at random from the 120 students. Events X and N are defined as follows. X is the student is in year 1, and N indicates the student plays netball. Find probability of X given that N. Well, this is not unknown to us. All of us know that how to solve this one. So for finding X given that N, first of all we will find X intersection between X and N. Okay, so let us write probability of X intersection N is equal to, let us see, X is the student in year 1. Well, how many students are there in year 1? Then N is the student plays football. Okay, so total number of student is 120. Well, as one out of 120 students has been chosen, so total number of student is 120, whereas the student belongs to first year as well as netball is nothing but 12. Okay, well, then we will find probability of the student who plays only netball. So how many students are there for playing netball? Total there are 40 students who play netball, who choose netball. So 40 and out of 120. Then they have told us to find the probability of, hence we can write probability of X given that N equal to, we know how to write this, all of us know how to write this. It is probability of X intersection N over probability of N alone, and we have already obtained the required data or information. What is that? Yes, so it is going to be, probability of X intersection N is 12 over 120. 12 over 120. Let me erase this. Yes, let me write again. So it is 12 over 120. I will have to zoom it out. Well, then it is going to be 12 over 120. 12 over 120, and probability of the student playing netball is 40 over 120. 40 over 120. So finally what are we going to get? Look, 120 and 120, both of them are denominator. If we divide, they will dissolve each other. It is going to be 12 over 40. 12 over 40. After simplification we can write as, if we divide 12 by 40, let us do the division. 12 over probability is 0.3. 0.3. That is the answer to the first question. Let's see what the next question says. Next question says that probability of n given than x. So it's almost similar to the previous one. If we write probability of with a different ink, so probability of n intersection x, we have already found this. This is 12 over 120. So 12 over 120, and probability of n alone n, sorry, alone x, means the student belongs to first year. So total how many students are there in first year? There are 16 plus 12, 16 plus 20 to 38, so 50, and total number of students is 120. So it is going to be 50 over 120. 120. Well, so we will find the probability x given that n, so or n given that x, n given that x, x is equal to, we know how to write this, probability of n intersection x over probability of n alone, x alone, not n, x alone. So already we have got the information. Probability of n intersection x is what? 12 over 120, 12 over 120, and probability of the student being x is 50 over 120, 50 over 120. So it is actually 120 will dissolve each other. It is nothing but 12 over 50. If we divide 12 by 50, let us see what it is. 12 over 50. It is 0.24 is our probability. 0.24. 0.24 is our final answer, and these two are the most common question, and there is nothing twisted here. Let's start reading question number C. Determine whether or not x and n are independent events. So they have told us to determine whether x and n are independent or not. So what is the formula? First of all, we will have to find n and x, intersection of n and x, probability of n intersection x. Already we have found n intersection x is 12 over 120, and probability of n multiplied by probability of x alone. If we find the probability of each of them individually, I mean product of the probability of each of them, it is going to be, look, x was what? N was 40 over 120 and x was 50 over 120. So 40 over 120 into 50 over 120, 50 over 120. So finally, if we dissolve the zeros, it is going to be, okay, and it is 1 over 10. 12 tens are 120. Then a 4 can dissolve this. 4, if 3 or 12 is divided by 4, it is going to be 3. So finally, the product of individual probability is 5 over 36. 5 over 36. Then what will be our comment? Finally, we will write since. Let me write over here. Since probability of x intersection n is not equal to individual probability of x, product of individual probability of x and n not equal, then the events are x and, we can write x and n are not independent, are not independent. So if the product, individual product is not equal to the combined probability, then they are not independent. Well, then we are moving on to the immediate next question. What is the immediate next question? Question number C. Question number C says one of the students who plays netball takes 8 shots at goal. On each shot, the probability that she will succeed is 0.15 independently of all other shots. Find the probability that he succeeds or she succeeds on fewer than 3 of these shots. Well, first of all, we'll have to determine the category of this distribution. If we have a proper look at the question, look at this here. The total number of experiment is given 8. He tried 8 times. Look, total number of experiment is 8. 8 shots. And probability of each shot of success is 0.15. So it belongs to binomial distribution. Let us write x belongs to binomial distribution. And you know, the parameters for any binomial distribution are n as well as p. N is the total number of experiment, which is 8, and individual probability of each shot is 0.15. Okay, that means p is equal to 0.15, hence q is going to be 0.85. That means remaining probability is 0.85. Well, now we are going to find fewer than 3 of these shots. Okay, now we are going to find the probability of x less than 3 shots. Okay, so x less than 3 shots means he might be succeeded when there was no success. Okay, and he might get succeeded when x was 1, or he might succeeded 2 times. 2 times. Fewer than 3 means he might not succeeded, and he might be succeeded once or he might be succeeded 2 times. So let us write out of 8 shots, if there is no success, then what will it be? Probability we have already got 0.15. 0.15 0 times, and 0.85 how many times? 8 times. Well, plus he might get succeeded once. So probability of succeeding once, and he failed 7 times. Probability of each failing is 0.85, and he failed 7 times. Okay, or he might succeed 2 times. Okay, so success is 0.15 and he succeeded 2 times, and 6 times he failed. 8, sorry, 8, 5, how many times? 6 times. Now we are going to calculate these. So let us calculate these. Before calculating, we are going to simplify this. If we simplify, 8 choose 0 is actually 8. Okay. So 8 into 0.15, no, 0.15 raised to 0 is it's 1. Okay. And 8 choose 0 is not 8. It's actually 1. 8 choose 0 means 1. So first quantity also 1. There remains only 0.85 raised to 8 times. Plus 8 choose 1 is actually 8. Well, then 0.15 and 0.85 raised to 7. Then 8 raised to, that means 8 choose 2. Okay, 8 choose 2 is 8 factorial. 8 into 7 into 6 factorial over 2 factorial as well as 6 factorial, and then 0.15 raised to 2 and 0.85 raised to 6. 0.85 raised to 6. If we simplify this step, it is going to be 6 factorial and 6 factorial can dissolve each other. So finally, what is remaining there, or it is going to be 0.85. Let us calculate directly. Okay, so 0.85 raised to 8. 0.85 raised to 8. 0.85 raised to 8. is 0.895 is our final probability. So I think you have understood this. This is nothing but binomial distribution, and we applied the expansion of the binomial distribution. So that's all about the first solution, and let's move on to question number 2. We can write this answer. We can write this answer just beside this. Let it be written over there, 0.895. Okay, this is our final answer. Well, question number 2 says, question number 2 is, find the number of different arrangements of the 9 letters in the word algebraic. Okay, so we know that whenever arrangement is the question, we apply the concept of permutation. So let us write number of arrangements. Number of, let me change the ink. Color of the ink should be this. Number of arrangements, and we know that for arrangements we apply the concepts of permutation. So there are 9 letters, so 9 factorial ways they can be arranged, and we will just divide by the number of identical letters. Let us see how many identical letters are there. Are only 2 A's as identical, so it will be divided by 2 factorial or 2. So finally our answer is going to be, if we divide 9 factorial by 2, it is going to be 181,440. 181,100 181,400 ways these 9 letters can be arranged. 4, not 400, it is 440. It will be 440. So it is 440. Well, then the immediate next question says that find the number of different arrangements of the 9 letters in the word algebraic in which there are no more than 2 letters between the 2 A's. So between the 2 A's, it cannot be more than 2 letters, but it can be, what are the possible cases? And let us write, there are total 9 letters. So what are the possible cases? One after the other, we will analyze the cases. 1, 2, 3, 4, 5, 6, 7, 8, 9. There will be a 2 A's. They have told that it cannot be more than 2 letters, so there may be no letters, 0 letters. Okay, then for the second case, 1, 2, 3, 4, 5, 6, 7, 8, 9. Among these 9 letters, there may be only 1 letters in between a. Okay, okay, what may be the third case? 1, 2, 3, 4, 5, 6, 7, 8, 9. So first letter is suppose A, and in between them there are 2 letters. So these are the 3 possible cases when there are no more than 2 letters. There, that means there may be no letter in between A's, and there may be 1 letter in between A's, or there may be 2 letters maximum in between A. Well, so we can write number of arrangements is equal to number of arrangements equal to, let us write just below this. Okay, number of arrangements. First case, look at this. If this is a box, look at this. A's are in one box or one unit. So how many units are there total? Total 8 units, including these 2 A's together. So there are 8 factorial ways they can arrange. Okay. Then second possible case, plus, or suppose there is one letter in between A's. So what will be the cases if there is one letter? So total there are 8 letters, 8 remaining letters except A's. Sorry, not 8, it will be 7 letters. If two A's go away, then total there are 7 letters which can interchange their position among themselves. After that, such box, there is one letter in between A. So in this box, how many positions are available for this box? This box can be over here, they can shift over here, or there, or there, or there. So how many possible cases are so? Already there is one position, and 2, 3, 4, 5, 6, 7. So 7 more ways they can be changed their position. That means 7 times they can change their position. Well, the third possible case, in the third possible case, this is the box. Okay. Now 8, there are 7 letters, remaining letters except A. So 7 factorial ways those letters can interchange their position. And what about this box? This box can change their position how many times? So once, twice, thrice, 4 times, 5 times. So 5 plus 1, 6 times. They can change this box. This unit can change their position 6 times. So finally our result is going to be 8 factorial into, let us do calculation, 8 factorial plus 105,000, 105,840. 840 ways they can be arranged. So that is the final answer to this question. So this is the solution to question number B of the second questions. So that's all about the solutions of these two questions of this paper, first two questions. And I believe that you have remained attentive while learning this, and I'm thankful to you to be with me while listening to this. And may Allah bless all of us with the beneficial knowledge. Fi amanillah.